Cool. And let me also unmute. Hello, everybody on Twitch, and hello, everybody on Zoom. So, welcome to the September DC207. We're happy to be back again here at the Open Bench Project, and happy to see all of you online also. I hope you all are doing well, and thank you all for coming in person. One big thing first, if you want to join the chat for a long period of time, make sure you join mainsec. If you go to mainsec.org, you can sign up in self-service and join the conversation after DC207 and have a great chat with everyone we know. But without further ado, I will introduce Mr. Scott Ellis, who will be talking to us about abusing GitHub Actions. And so let me hand you the mic here, so excuse any sound.
Well, hello everybody. Welcome. So today, my name is Scott Ellis, and I work at IDEX as a security engineer. And today I want to talk a little bit about supply chain attacks, and in particular, GitHub Actions. So I've given this presentation several times at work to a different kind of audience. So I'm just going to go through some slides, just basically what GitHub Actions are, how it applies to how we build software and stuff like that. But I really want to focus on the demos at the end. So if you know everything about GitHub Actions already, then you can just kind of just glaze your eyes over for a few minutes while I get through this. All right, so software supply chains. So we're a software development company at IDEX, at least part of us are. And so a software supply chain is everything that you use to build your software. So it's the code, either we write it, or we buy it, or we use open source stuff. And nowadays, a lot of it is open source. And then it also includes all your tools to develop software, your IDEs, compilers, plugins to your IDEs, and things like Git and stuff. So that actually, IDE plugins is actually a topic for another meeting if we'd like to do that. And then also there's the testing tools that we use in our software, and then things like code scanners for CVEs, stuff like that. And then there's actual CI/CD DevOps kind of tools like Jenkins, Travis CI, Maven, Bamboo, and kind of the new kid on the block is GitHub Actions. Now it's not real new. It's been around for a couple years, but really only officially, I think, the fall of 2020 was when it went full 1.0 kind of status. But it's at least in the world that I'm living in, it's the new shiny that all the developers want to use. So real basic stuff. Git is how we manage our source code. It's called a version control system. And GitHub is really just a front end for a Git server. And it's won the battle. It's the most popular Git service right now, and popular enough that Microsoft bought it a couple years ago. So GitHub Actions, right? So this is the marketing blurb that they talk about on GitHub, what GitHub Actions are. It's basically the popular tool for the DevOps guys. This is what we use to run our builds for software, how we run our tests, how we version our software. We push it out to places where it's destined to go. So that's the official marketing term. For me, the GitHub Actions, as soon as I saw it, I just saw it as cool. We can run any code we want on, and you'll see later, arbitrary computers all over the world, which is pretty slick. So GitHub Actions. So basically a runner for a GitHub action, and that's what they call them, a GitHub runner, can be on pretty much any type of machine. GitHub supports a module, a service that you can run on your computer to act as a GitHub action. But GitHub also provides runners for GitHub Actions inside of their service. You can use them for free. A lot of organizations that are of any size will actually run their own server farms for GitHub Actions. And then, of course, if you want to run it on your own workstation, you can run a GitHub Runner. And that's pretty much what I'll be demoing here. So what kind of GitHub code can you run? So without doing any work, you can just run bash shell scripts, PowerShell scripts. I haven't really played with the PowerShell stuff. I'm mostly a Linux guy. You can run programs that are part of your GitHub repository, or scripts that are part of the repository from where the GitHub action is getting launched from. And then you run these GitHub actions on these GitHub runners, which are another machine, and you can execute the code that's on that machine. So whatever's on your host, you can take advantage of and use that. And then there's also the case of these third-party actions. So as soon as this started becoming popular, people started realizing that there's a lot of code reuse opportunities here. So GitHub provides what they call a marketplace for GitHub Actions, but they're really no different than the code that you would run yourself. The problem here, as we'll see, is that they actually get to run your code just like you. So they get access to all of your code. They run on your servers, and they're not well controlled. All right, so like I said, we're going to do demos of all these things, so I'm going through this fairly fast. So you can trigger GitHub action events with normal Git operations, pushing code up, pulling code. You can run it on a cron-like scheduler. There's a user interface or an API that you can use to trigger GitHub events. And there's probably more that I don't know about because it keeps growing. And so basically GitHub Actions, they're just set up. This is just a YAML script, and they're broken up into a workflow, which is the whole thing, broken up to a series of jobs, and each job can have a series of steps, and each step is actually a script or a program that you actually run. So there's a hierarchy to them. Every one of the jobs can choose to run on a different server or a different machine. Just something to keep in mind. All the steps will run on the same server as their job and workflow. And then there's one other thing, and this is really where the crux of it. So for these CI/CD jobs to run, they need credentials for other machines. Commonly, sometimes you don't, but and really that's the target that we're looking at when we're trying to attack a GitHub action. We're usually trying to get secrets that we can use to do something else. I mean, it could very well be that the code is all you're interested in and you just want to get to that code. Could be that you just wanted to inject some code into that particular repository. But really, if you think bigger, what you really want to be is on the machine and have the credentials to access other machines inside of an organization. So that's the target. And then there's that GitHub Action Marketplace. Like I said, there's about 10,000 different actions that are available. So these are just free plugins that you can choose, and I'll show you how easy they are to just bring them into your GitHub project and use. And they have access to everything. So let's go to just do some demos first, so everybody can get a better idea of what GitHub Action is. So I'm going to start with, I have a very simple program here, right? It has the basic hello world. I have a make file, right? I can make it cool, right? The way GitHub Actions work is you just set up a directory like this. And you create a YAML file. And if you put this in your GitHub repository, GitHub understands this and will actually execute it. So in this particular case, what I'm saying is I have a job. I'm calling it build. I want it to be invoked anytime that a push is done to the repository. I want it to run on one of GitHub's servers. So GitHub has their own servers, and this is a way to label one of the GitHub servers. I say I want it to run on an Ubuntu box. You could choose a Windows box if you wanted to. And there's a couple steps to this. When I want to run my make, the first thing I have to do is I have to check out my code on the server. So I use an action, a third-party action. This one actually comes from GitHub, and it's hard to do very much if you can't actually get to your code. So there are some actions where we kind of have to trust the system. GitHub already has access to my code anyway, so I don't feel there's a huge risk here. And then the other step is just a shell command. I'm just going to call make. That's my GitHub action. So a very simple one. I'm going to run it. Ooh. Make my browser bigger. Okay, did it work?
Yeah, keep doing that.
Yeah, keep doing that. It's going to totally screw up my workflow, though. All right. All right, so this is my action screen. Nothing's happened yet. We haven't done anything. I'm going to make a change, and I'm going to push my repository. So, all right. Okay. Now, what we ought to see here is my action kicking off. Then what happened to the network?
I think it's tuning the amount of bands I'm using.
All right, so here it ran my GitHub action, and I can go look at it. So it has several steps. Set up the job. Basically, that's setting up the runner that's going to run this job. All right, we're not refreshing very fast here. Anyway, it's not too exciting. It did the checkout of the code. It ran make. It cleaned up afterwards the GitHub runner. So that's a basic GitHub action. So you could do that if you were a developer, and you could continue to write your code, push it, and then your CI job could be a lot more complicated than that. Maybe you want to distribute the code somewhere, maybe you want to run a code test or something like that. This is very simple. But people don't usually want to dig down into GitHub to look for the results. So one of the common things you'll do is like you'll post the results to a Slack channel, for instance, or Teams or something like that. So let's do that. So let's visit the GitHub Marketplace, and there's a lot of actions there. Let's just look on. Let's look for an action that can do a Slack post. All right. So I'm choosing this one. It's a popular one. It's way up there. And what they do is they tell you, when you look through this, they tell you how you have to modify your GitHub Action YAML in order to use this GitHub Action. So this one is actually very easy to use. And I'm going to cheat so that I don't mistype something here. All right. So now if I'm going to post to, well, first off, I'm going to add another type of dispatch event. So I don't have to push code every time I want to run a demo for you. I can use the GUI that GitHub provides to do that. So, all right, I'm going to push to a Slack channel. Well, obviously, I need some credentials enabled to push to that Slack channel. So, trust me, you're not going to have to watch me type too much longer. All right. And I'm going to add another step to this. And so we saw up there, this is the name of that. This is the repo name. They have to be GitHub repos, and they have to be public. Slack. And this right here is the tag for the Git repo. So it's pointing at some commit. That's the one I want to use. And then you can provide arguments to these guys, to your GitHub action. And this is the argument that this guy wants. All right, status. And so the GitHub action actually provides some status. And so this, I'm just taking advantage of one. And this right here, normally if one of the steps fails, the GitHub action will abort. But I would actually like to see the failures in my GitHub action if it fails, so I just tell it that I always want this to run. All right. All right. So this is going to fail now that I run it because I haven't told my GitHub action what my secret is yet. So I have to go in and do that. So it's running. It shows the commit that I did. I just gave it the name A. And this is going to fail unless I left the secret in there. All right, so here I'm waiting on the GitHub infrastructure to pick up my action, so I'm waiting for a free runner.
Can that be queued up for like some time, like while you wait?
Yep, and they explain all the timeouts that they have for the jobs and stuff. And that's one of the reasons also that people will use their own runners, so you have more availability. So for instance, IDEX has a farm of runners that they use for just my department. And shortly afterwards, I'm going to switch over and use my own runner for my machine. I just wanted to show you this first. So anyway, while we're waiting for that to kick off and fail, we can go over and look at secrets for this repository. Oh, okay, I still have the secret there. So this is where I would declare secrets like that webhook URL, you know. But I already have the webhook URL for that. I left it in there. So let me come back. And we're still waiting on a server.
I have a question about the YAML file.
Yep.
That run parameter, does that just take any operating system command? Or like, because it says make, but can you just put like anything?
Yeah, pretty much. If
Wow.
if the yeah.
Someone's probably doing that.
Yep, you can use any shell commands. A lot of people will just write just their full bash script right there in the YAML.
Oh. Okay.
All right, so it ran, and if we look at it, it looks like it succeeded because I did have a secret there. And if I go over to look at my Slack channel, I have this post right here. So it just ran and it posted that I had a successful job. All right. So that's how it's supposed to work. All right. And so enough of the good stuff. Now let's go start breaking it. So one of the things is there's those secrets in the repository. This one is not really a security risk because I'm assuming that you probably already have access to the repo. But sometimes you'll look at those secrets and you'll want to know what the values are because the guy who did them, put them in there, doesn't remember them or doesn't want. All right. So normally GitHub will obfuscate those. They won't let you see them. And in fact, if I go to try to look at this, I can update it, but I can't see the old value. So they're write-only values. Right? But obviously, GitHub knows what they are, right? It has to know what they are because they pass them off to your jobs when you run. So sometimes you just want to be able to see those as well. So there's a fairly easy way to do that. Let's first modify this and just do something like how about right, I'm just going to dump the environment from the GitHub runner machine. I'm going to sort it so I can see the variables easier and I'm going to see what we see. Right? So and so what I would expect to see when this runs, inside of the log that GitHub shows me, I should be able to see all of the environment dumped down in the log there. Because everything that is just like other jobs and stuff like that, cron jobs or something like that, whatever you pump out to standard out is going to show up in the output there. I think we got to stop streaming, man. You're killing the bandwidth. Okay, so I got my message from the Slack channel posted again, so that's cool. All right, so now let's go look at the variables. In this step here, there they are. There's the environment. That's cool. But if we look, I'm not seeing mine. My Slack webhook URL. It's hidden from me. And what did I call my other one? My secret? I don't even see it. Oh, because I didn't export that. So if you look at my YAML file, I exported the Slack webhook at the build level, which means that every job and every step saw it. I didn't export the my secret anywhere, and so this step right here never got to see that variable at all. Right? So that's okay, and that's actually a defense mechanism that you'd want to use. But anyway, this Slack webhook URL, I really want to know what that is because I forgot it, right? So we can fix that. Because it's not rocket science, right? So we know that it can give that value to all of the jobs. In fact, if that script was actually using it in some, it would have the value there. The only place it's being hidden from is the output here. It's just doing simple string searches for the value that it knows, right? So we can get around that pretty easily just by, right? So that's not really a hack, but that's just a useful thing to know how to do when you like forget the variables or something like that, or you want to see what the password was that somebody's actually using. in another Git job. So we'll get to more meaty stuff here in a second. Okay, should be there. Oh, it's not encrypted. Alright, now here's because my screen is... I gotta make my screen bigger. I should have just grabbed one variable instead of all of them. But so everybody saw what I did there. So I just grabbed it, and I'm just going to decode it, and now I see all the variables there, and there's my Slack webhook URL. Right, so cool. So that's just a nice to know trick so that you don't have to jump through hoops to figure out what your variables are. All right, so now let's get to something more meaty. So that GitHub Marketplace, what I'm saying is it can't be trusted. And one of the things that can't be trusted is the fact that it uses Git tags to identify what version of the GitHub Action repo we should pull from. So I'm gonna abuse that, right? So we saw that there's some 200 different Slack actions, right, in the GitHub Marketplace. So now there's going to be like 142, right? So I'll add another one. Now, actually, I'm not going to check my name because I know it's malicious and there's no reason to do that. Somebody might accidentally use it. But all right, so you can write your GitHub Actions in JavaScript, or you can, and then you're restricted to JavaScript, or you can write them in as a Docker file, which means you have no restrictions. You do whatever you want, right? If you put in your Docker file. So I have a real small Docker file. You know, I just install, I need curl because I'm going to be sending my Slack web post, right? And I need some certs. But otherwise, it's just a basic Ubuntu machine. And my entry point is just this Slack script. And it doesn't do anything. It takes I need the webhook URL to curl it to, and I need the message you want me to send. And that's all I do. And it works. And I'll prove that it works. And one of the things I've already done with this is, and I'll just go ahead and do it, Git. I'm going to tag this right here as version 1. Right, so make sure the repository knows that's version 1. And I have a little README that tells people how to use my Slack Action webhook. I'm going to use the same webhook because I'm going to post to the same site. And basically, what I want you to do in your YAML is tell me what message you want me to send and tell me what webhook you want me to do. You can use environment variables if you pass to your web things. I'm using actual command line arguments, and I'm going to pass to the thing. There's multiple ways to get your secret into your action that you want to send it to. So this is the way that I chose. So that's available. It's in GitHub. Slacker, right? It's a public repo. It's right here. So I need to modify my YAML file to use that. So my repository, I'm that v1, and I want a message. And I actually want webhook here. Again, this is just how I chose to set it up. I was using another one for an example earlier. So, right. So that's it. So now we're going to use my GitHub action, right? And so I'm just first going to just show that it works. And I don't actually need this anymore. All right, you'll see that when mine posts, it won't be quite as pretty. I didn't do any. Nobody's ever going to use my action because it doesn't do GIFs and stuff. But that's okay. I don't want anybody to use it anyway. So I just want to prove that it works first, and then I'm going to do the exploit. And the first exploit I'm going to do is actually the most popular one. It's the one that the Codecov hack. So I'm going to demonstrate that as soon as this finishes. Okay, and so I got my action, and I posted, and this is mine, GitHub Action build. This is my Slack post, right? So built, success, cool. No problem, everybody wants to use that one now, right? Now, and this is the important thing to remember. From here on out, I am never going to modify this hello world application. I'm not going to touch the workflow at all. I'm not going to touch the source code at all. You have to think of this as a supply chain attack. This, you saw that GitHub.github workflows, it's buried down in there. You probably have multiple workflows. They're sometimes long. Nobody likes to look at them. And once they're working, you just, they're hands off. They just work. You know, I get my post to the Slack every time I push a build, and it just works. Nobody comes back and revisits these. And I'm not going to touch this code anymore, but I'm going to continue to abuse this hello world application by basically playing with my Slacker repo as if a bad guy took it over. Or maybe I guess got short on funds and I need to take it. I mean, these are just, anybody who wants to use these things can do it. All right, so just to save some typing, I've already create some branches that have my differences. Oh, sorry. All right, and the difference between this one and the previous branch was, well, nothing in there. In this one, all I changed was the Slack script. All right, and I just added this line here. What this is doing is posting to a separate Slack channel at the same time. Now I just, getting a little full of myself, and so I base64 encoded it and all that stuff, but pretend so you don't really know where it's going. But that's just another Slack webhook. All right. So you don't know this happened. All I did was slip one more line into my action, and you're just using it as a third-party action and stuff. But now I'm going to, and here's where we abuse the git tag thing. I'm going to say this is tag v1 now, right? I'm pointing it at this commit now. Right? So I didn't modify the other repo at all. So now I'm going to go use it here, and I'm going to take advantage of the fact that I can run this without doing a push. I can just go to, and I'm confused now. I can't see everything because my screen's too big. I gotta, right there. Because I added that other workflow, I can just run it from the GUI here, so I don't have to do a commit. So I'm just going to run the action this way. And it's going to run. It's running the same commit as before because I haven't changed any of my commits. But now I'm going to get my success here as soon as it finishes. All right, so we got it. That's cool. But I also posted to another channel. Oh, come on. Why didn't that work? DC207.
Vanguard, the demo runs fairly.
Ah, this has to work though. Otherwise we won't see shit. Sorry. All right. What could be wrong with that? I just want to double check. That's correct. Oh, I pushed the wrong thing. I got to push the tag up, not the branch up. All right, so the tag never went up to GitHub. So that tag never got changed in GitHub. So, all right, sorry about that. So now if I run it again, this time, now I'll see the Slack post go to 2 places. Sorry about that, ruined the flow. So, like I said, this is exactly what happened to Codecov. So Codecov is a company that does code test coverage and posts the results up to web servers so you can look at it all nice and pretty, how well your code's doing like that. And lots of companies use it. Lots of security companies use it just to prove that they're doing all their code stuff. Yeah, and they got it bitten by this thing. And so if we look, and this is actually, to be honest, this is the most damaging piece of the whole hack of the whole thing, because I don't have any secrets in my GitHub action. This is trivial, it doesn't have anything. A lot of times there'll be AWS keys in there, there'll be HashiCorp Vault keys in there, there'll be database keys in there, Artifactory keys. They're all there because these GitHub actions are talking to all these other servers with the code. And there'll be SSH keys to other servers on there sometimes when you're pushing stuff around. So, and this is exactly what happened with Codecov. The normal operation still behaves the same. Developers have no idea this is happening. And because of, if you noted the way I did the git push, I make sure that I keep curl silent. So none of the results of curl show up in the log. And if we go to look at the log in the GitHub action, you can't see any trace that I did anything that I wasn't supposed to be doing. If we were to look at this Slack post, you have no, this is only the valid post that goes out. You have no sign of that the other one happened. So unless you went back and looked at that third-party action, or the way Codecov was caught, some network guy caught activity going to servers that shouldn't have been happening. But most people don't watch that kind of stuff from the GitHub Action Runners. So they never got caught. So a lot of companies lost a lot of secrets that way.
Wait, so you have to check in that, well, you didn't check in, I'm sorry, but you committed it, so it's not in the log? I might have missed
It's
that.
in my log, but I'm a third-party repo that you're just using. Unless you're looking at those third-party guys all the time
Oh my god,
and
cool.
seeing where their tags are pointing to.
That's too crazy.
Yeah.
Cool.
So all I did was, so it's the same repo, same thing. You haven't changed your code at all. I just, on my side, I just move where that tag points to.
That's wild, because like git logging is so good, but it doesn't matter when it's distributed like that. Like, so, damn.
Okay.
Can anyone publish to the marketplace?
Yes.
Okay.
All you have to do is have a GitHub account.
That's
Now,
great.
so the hard part is to get somebody to use it, right?
Yeah.
Because I mean, look how fancy their post is, and mine is just like Yeah, who knows gonna ever use mine? But I could make it pretty, right? All right, so that's hack number one. Our second one is, all right, so GitHub Runners, I'll to this point I've been using the stock GitHub Runners, but here I am going to change the workflow just this once. I want to point it to a runner on my machine. All right, so let's go over here on the Hello World application. I can specify what runners I want to run on. And so my runner, I'm calling it 7730. This is this machine here. And it's very easy. I'm not even going to go through the details of how to set up a runner of your own because it's so easy that you can just follow it. You just download this binary, a bunch of files, and then you just run config. It tells you right in the GitHub. When you say add a new runner, it tells you exactly what command to run on your shell. And then once you've done it once, you just run it like that. It's connected to GitHub. So now I'm running something from within my network that's polling GitHub to say, hey, you got any work for me? And that's what's happening. And it's associated just with my repo. Now, if you are in a bigger organization, you'll have a farm of these things, and they'll queue up and they'll take jobs. You don't have to worry about that for this particular presentation. So right now I have a self-hosted runner. It's idle. It's not doing anything. And for this particular runner, I'm the only one that can use it. This Hello World application is the only one that can use it. So I do have to make one change to this repo now. I have to tell from now on when you run these runners, run them on, and I didn't give it a name, so it's just self-hosted. You can give them names, and you can have pools of them and stuff. So that's without changing anything else, and just to prove that that works, I'm going to run it. We can watch the action runner log here. I'm going to go back here, just kick it off again. Right. I'm waiting for GitHub right now. So what I want to do is put it on a runner of my own because I want to show that I can get a shell on that runner, right? So I can get a shell on the Ubuntu runners. I can get a shell on my host. I can get a shell on the server farms runners. So that's a nice thing to be able to do, right? Get a reverse shell on a box. All right, while I'm waiting on GitHub up here in the corner, does everybody kind of familiar with what a reverse shell is and why we would want to use them? So, a lot of times when you're trying to get, you're hacking somebody, and you'll get your code to run on their machine or something like that, but you'll be stuck behind a firewall on side of a LAN, and you can get out, but you can't get in from the outside. And so what you have to do is establish some sort of, phone home, basically. And it's nice if the phone home connection actually gives you a way to get back in this way. All right, so, normally if I got my bad code running here, as an attacker, I still don't know that it happened. You can send out, but a reverse shell actually connects this way, but gives me a shell back here, right? And because I'm a nerd, I wrote it in assembly, but but the really nice thing about reverse shells is you don't really care too much about like the distro or the version of, say, Linux that I'm using and stuff, because what we're really doing is just using some syscalls. Actually, I'll show you. So a syscall, a reverse shell, just consists of 3 syscalls. A socket call, which basically just sets up what type of TCP/IP or UDP, what kind of socket you want to use, and then the connect call, which opens up the socket, And then what you want to do for the reverse shell to work is you want to associate standard in, standard out, and standard error with the socket. And that's really all it does here, right? So I have a create a socket. Now the IP address, you have to specify when you open up the socket and what port you're going to go to. The connect, well, not when you open the socket, but when you do the connect call, you have to specify those informations. And then this dupe2 call is where I make standard out, standard in, standard out, standard error, all point to the same socket. Dupe2 just does that for us. But the important thing is I'm not using glibc or anything like that. I'm just using syscalls. So because I'm just using syscalls are really easy to do in assembler. And the advantage of assembler is I don't rely on any libraries, and I can make my code really small. So about the only thing I know how to do with assembler is write reverse shells. All right. All right. And so you can look at it. You don't have to know this, but it really does just consist of the same things that I was doing before. I create a socket. I do a connect call. And doing syscalls means just putting a number, a syscall number inside of a register, and then doing the syscall function. And then I do the dupe, which is just a loop over. I did the same loop 3, right? But the cool thing is it's so small, right? So my shell code, so I compile it, and it's 704 bytes, but I can base64 encode it and encrypt it, and it's only 337 bytes, right? So it's very small. So now let's come over to here. All right.
Question, Scott.
Yep.
In that directory you were just in with the assembly,
Yeah.
the R shell, the executable there, is
Yeah.
that just the output of that?
Yeah. Yep. And then, yeah. So let's look at the make file. Yeah. So our shell is an asset. Yep. All right. So I want to go back here. All right. All right. So this branch now has a few differences. One, it's my Docker file that my GitHub Action is running in, right? So I can put whatever tools I want in it. And this time I added a couple more tools that I just want to use, right? So Git we'll use later, but OpenSSH, client, some utils that I can move around the network a little bit. But I want those, and I added this file called signing, right? Because I want to kind of obfuscate, because I'm using it in my Slack script here. I'm saying I want to check signature. I do some work, right, with that signing file, because it has my public key in it, right? Well, this right here, this is my shell code. That's my reverse shell. And yeah, you can look at this, and it's like guaranteed to make people's eyes glaze over. But all I'm doing is extracting it, you know, uncompressing it, extracting it, putting it in a temp file, and executing it. All right. So I compile that code with a known IP address of a server I have out on the web. So, and I'm going to, I'll start a listener there. Now, back over here, again, I'm not going to modify the code in the hello world, right? But I have to change my tag. So, what did I do wrong? Okay, that's right. Git. All right, so I did it right this time. So, again, all I did was change the tag in the Slacker repo that's getting pointed to by v1. And now I'm going to run my GitHub repo again. So if this is for real, right, we'd be waiting for the victim to go do another push to the repo. But I'm just going to do it by using the GUI. I'm going to run the workflow. And now, since it's more exciting, I'm not going to watch that. I'm going to watch over here to see if I get my shell. Any questions while we wait on this? It shouldn't. This is not the code that's taking a long time. This is GitHub is actually pretty slow right now.
So you're going to run this code. You're connecting back to your computer right now because the runner is your computer.
Yeah.
But you could do this on
Any runner.
GitLab.
Yeah, I could. You can get on the GitHub Runners, or you can get on. They're pretty isolated. They make sure that only your code runs, because obviously I'm not the first person to think about this, and but like in an organization, you get on the server farm, and usually all the machines can talk to each other, and they can talk to other servers and stuff. So I have a runner here, right? I'm connected back to me, and the files I'm seeing here is because the GitHub Action has access to the source code that we're running. But I am, let's see. Right, so I'm running in a Docker container, but my IP address for the actual machine is 192.168.1.20, right? And inside here, now I'll get to a better shell in a second, but right, so I'm 0.2. I'm the first Docker machine running inside there, but I do have access. Oh, gotta be careful here. Let's see. Otherwise, I'll get logged right back out. What did I say it was? .1.20. And, well, probably .1.1 is the router that's right outside there, right?
Sure is.
Should be, well, maybe it's not letting me do pings, but
Should be responding things.
let's see. Nope. I'm not sure why that's not working. Any ideas? I should be able to see right outside. Normally I can. So my Docker container 172.17.0.196.1.20. I'm not sure why that's not working. Any ideas? Nope, I don't. No, I shall be able to ping out from this machine, route it out, right? I should be able to like, at least ping this host. Oh. Anyway, we'll come back to that because the next example is going to use the same thing. But all right, I would have expected to have been able to ping at least this guy and probably any other of the hosts in there, because I'm just a container running on my laptop here, but I'm not blocking any of the network traffic. So I should have been able to talk to things. So that's useful. The last attack, though, I like this one. So you saw that I have access to the source code. it also turns out that GitHub at the same time gives me a token that lets me interact with the repo. Because one of the things you might be doing with this repository with your GitHub action is creating another tag, your release tag or something like that. Or you might be handling pull requests or something in your GitHub action. So you need some privileges on the GitHub repo. But we can abuse that as well, because if I can get a shell onto your machine there like that, and I'm going to run this workflow one more time. Oh, wait. This is not good. It hung. I'm going to kill the runner and start it up again. So it's hung in my runner. All right, let's try it again. Sorry this is taking so long. Normally this stuff runs pretty quickly. So GitHub is not wanting to give me a job anymore. Maybe I'll switch to using the Github Runners.
I think they're on to stuff.
I kept thinking that, but I've run this so many times now that I figured, nah, no, they can't be watching me. They would have stopped me a long time ago. I'm just abusing my machine too. I'm not like on theirs. Come on. Cancel never actually works. I don't even know why they put that button there. All right. How about this? Let's just do it using the GitHub runner. And maybe that will work.
Like a runner on GitHub?
Yeah.
Oh, okay. Are they
So
gonna like that, or is the show?
I don't care.
Okay, sorry. I'm not a cop.
I'm not a cop.
I'm mailing the GitHub security team now. Obviously, there's no excuse for self-abuse.
All right. All right, so that one kicked off automatically. Okay, so we got a connection from 104. So this is now I am on the. This is the GitHub runner.
Yikes.
Right, so I'm on there. But it doesn't matter. It's just another machine, right? Well, it's not. I mean, These actually are, they're so generic and they clear it for every user. So you don't ever see anything else. It's a lot more fun to get on a server farm because those runners just because they want to be faster and stuff, they don't often clean up. And so you can get on there and you can see all the repos at the same time that have been using this runner since the last time it rebooted or they cleaned it or something like that. So it's a lot more interesting to get on either a workstation or something. But
Virtual machines or something. Okay. Cool.
all right, so again we have the source code that's checked out here. So now I'm going to do something more malicious. So um, let's right. So said -I. Tell me if I do this wrong. Cool. So, all right. So I modified the code, right? So we have a dirty, and I want to check this in now, right? So, and to prove that I have a token that can do this, first I gotta set. Well, let's use a real name. You know, you have to set up that you get user and email and stuff like that. Otherwise, you can't make a commit, and it'll just screw up my shell if I do this. So let's just go ahead and find out a good user. So, all right, Scott Ellis. Yeah, we'll use him. All right, so because he's a reliable person, so we can. So now I'm going to git add main.c. How about this? Well, let's see if it went up anyway. Nope. What did I do? Cool. So I modified the source code. So we saw what I did. So again, I'm not really playing with the victims repo at all. I'm just playing. I own one of these GitHub Actions that they're using now, and I use that by just playing with that tag for the commit tag. And so I got a root shell on their or I got a shell on their machine, and from there I have a GitHub token. I can go modify their source. All right. So this could be a really big program. You could stick some really subtle stuff anywhere you want in their code base and commit it. You can use a user that already exists on the systems. You can mask this pretty well if you wanted to. I don't know. I think it's pretty cool. So if you're on the blue team, you should be pretty scared what your developers are doing, because when you go to the GitHub Marketplace and you see all those different options to do whatever you want with your code, I mean, they just get all googly-eyed, and it's like, we gotta have that, we gotta have this, we gotta use this one, even if they're as simple as this, like the Slack post, right? So, all right. So to be fair, I should say, all right. So what can you do about it? All right. So GitHub has some recommendations for hardening your GitHub Actions. All right. So I was using just the default behavior. And the default behavior was giving me a token that had full read-write privileges on it. You can actually specify that the tokens can only read if you want to. Now, sometimes that doesn't work because you actually want to write. You want to put a new version out there or something, and you got to give the token that privilege. But if you don't need to, then don't do that. Another thing is when we're looking at the secrets, all right, there's sometimes you'll see developers will, instead of specifying, well, this step needs this secret, and this step needs these two secrets, and this step needs this secret, they'll just put 20 secrets all at the top so that every single step gets them all, which is great because that means your GitHub action gets them all too, and you get to see them all. So one thing you could do as on the blue side is, don't give a step like the GitHub, like my Slack post step, right? It's nowhere in the world does it ever need AWS credentials, right? So you shouldn't expose those to that GitHub action. It needed the Slack webhook URL. That's it. So you can do that. There's other things. You can prevent reverse shells, right? I mean, the GitHub Runners should probably only be talking to certain other machines. You should probably have a fair idea about what other machines they should be talking to, not just some random Joe Schmo's server sitting out on the internet doing something. Docker, you can escape Docker containers. If you're running in privilege mode, you got root on your Docker, you got the Docker socket sitting there, you can do an attack on a Docker and try to get out of, you're probably running on a big box that has a bunch of Docker containers running, and maybe you can get out of that and get onto the machine itself. Other things you can do is you can rotate secrets, right? At least limit how long the damage lasts if they do get onto your machine once. So all these secrets that you're putting in GitHub should be rotated so that when somebody does do this to you, the things that they grab from you don't last forever. It's not terribly hard. So I've written there's a Go API to the GitHub org, and so right now at our org we rotate all of our vault secrets and our Artifactory secrets, and I've started working on the AWS secrets so that we rotate them so they only last a day. So if you do get them, so the difficulty is you have to identify which secrets you want to rotate, and then you have to encrypt them. So each repo has a public-private key pair. They give you the public key. You encrypt it using SALT, the typical NaCl library stuff, and you just encrypt it with the public key that they give you and push it back up in encrypted form. So it's not terribly onerous to use that API to do it. So you can rotate these secrets. I think that's it that I have. Any questions?
So, I have a question. How long can GitHub Actions run for? Like, are you
It's like 48 hours.
48 hours?
Yeah, it's really long.
Yeah.
Yeah.
So what's like stopping someone from, yeah, like just setting that up as like a place where you're going to be launching attacks from? Like, do you pay for those resources? Are they free or?
I don't know the details for sure, but I do know that crypto mining is one reason that you want a reverse shell on those things. You want to get a shell. That's the use for that. Because yeah.
Yeah, I only ask because like I know Azure they have like a similar thing in their DevOps stuff, but they've limited their own runners to like 60 minutes, like, and that's it. And you have to like go through a really weird process to actually get access to them, but this is just sort of
All right. So don't quote me. I know that's some big number, much longer than anything I've ever done. I was reading the documentation. I thought 48 looked like a number, but it was really long. I thought, man, that's ridiculous. But I don't know.
Azure before they did that, they actually had you could run a job for up to a week, and they actually had problems with crypto mining specifically.
Yeah.
What are some examples of actions that have been exploited? When we talk about the Codecov, what was
uh, s- I don't know.
Like, what were the developers using to add to their supply
Oh,
chain
so
from third parties?
Codecov is actually a commercial product, and part of their product is they give you the action to execute on your code. So I don't even think.
So they were compromised.
Yes.
Okay, so and then it went up to their customers that
Yes.
were using their action. Okay.
Yes. And they didn't even find it. A third party found it for them. Some attentive network engineer noticed that there's traffic going to, and they were actually posting it to Slack. I think was
So that's what
yeah.
the action was. Okay.
Yep. And I'll have you know, I did these presentations back in December and January. Before the Codecov hack, the first thing I thought was, no, wasn't me. But I mean, once you look at it a little bit, you just like, of course, that's obvious. That's exactly what I'm going to do if I can hack it. If I can use that thing, I can definitely abuse that. So, I think, I mean, so this is I've given this talk several times and it's fun. I think, but pretty much have used it up. I don't think there's any more you can do with this. I can get all your secrets, I can get on your box, and I can change your code, right? That's about all I can do with GitHub. I think the next thing to look at is IDE plugins, like for Visual Studio. I'm thinking that's like ripe for attacking as well. So that's something I'm going to look at.
So can you just restrict your developers from using third-party?
Oh, yeah, that's a good question. So right now, GitHub does not let you use private GitHub Actions, even within your own organization. So what we do, and so what we started to do at our company is when the developers are insistent that they gotta have this action, right? We clone it. We put it in our organization. We make it public, but we don't accept commits, right? So now we own it. So if that tag is never going to change unless we change it ourselves.
Okay.
So that's the workaround for it. But that means that, all right, the reason that GitHub recommends that you point your GitHub action at a tag is so that if the developers fix security issues and stuff like that, then you'll get those automatically, right? But that's just ripe for abuse. If you want to use that third-party action, you could point it at an actual commit instead of a tag, in which case none of these attacks work because you can't change a commit hash in Git. So the fact that they use a tag is what we're taking advantage of here. But that's the recommended use. That recommendation from GitHub.
Do you think that this is like, say, more secure than just having like a Jenkins box and deciding that that's what you want to use for your builds? You don't want to use these actions, right?
No, I think Jenkins is more secure. I think because you usually kept that inside your data center,
Yeah.
and yeah, it's just this free for all. It's that marketplace that kills me. It's like the developers will just go grab any shiny and bring it in and say, gotta have that. It's like it didn't exist 2 weeks ago. Gotta have it.
Well, Jenkins plugins kind of work in a similar way, where
Yep.
developers are like, "Oh, it's a plugin. I'm gonna download this," and there's literally no quality control anywhere in that space. So, yeah,
I think supply chain attacks on software is the sweet spot for the malicious guys right now. You have to be a little bit more patient. It's not immediate get into a box kind of thing, but you can collect on a lot of different boxes if you get something popular.
Grab that mic from you. Awesome. Well, thanks everyone for attending virtually and putting up with the hiccups on the internet. We hopefully will have a better time next month. And thank you all for joining in person, and have a great rest of your evening.